I'm Graham Butler. I'm IBM's Vice President for Energy and Utilities across Europe. That entails providing advice to our clients in the challenges that they face with the transformation of the industry that we're seeing, and that covers electricity, it covers gas, and it covers water.
Graham, what are some of the most exciting changes in the energy market at the moment? How is IBM involved?
I think some of the most exciting changes are what we're seeing on the one hand with the deployment of new distributed energy resources, and on the other hand with the changing expectations from customers and consumers and the way that they want to interact with their energy providers.
And tell us a little bit about how IBM's perspective is on where the industry is heading and what's driving the changes.
Yeah, so our perspective is that the industry is going to shift to a very different model from what we see today. Now, it's being driven in part by cost pressure, by regulatory intervention to decarbonize the energy supply chain, and it's also being driven by a change in terms of technologies that are coming to bear. And those technologies that are coming to bear are very much in the area of distributed energy resources. So what I mean by distributed energy resources, it's generation, it's storage, it's all manner of things like that. And then that's supported by changes that we're seeing with Internet of Things and the delivery of services and solutions over cloud.
Let's talk a little bit more in detail about distributed energy resources, as you say there. Tell us a little bit more about what they are and how they're impacting the industry at the minute.
Okay, so if we step back and we look at the industry and how it was, we have centralized generation, so big power stations, nuclear, thermal, hydro, and some of the larger scale wind farms. That power is produced centrally, delivered over transmission infrastructure, through a distribution infrastructure, and then appears at the meter. Distributed energy resources are all the things that can be done at the point of consumption. So we have solar PV, and you'll have seen panels going up on the roofs everywhere. We have micro wind. We have what they call micro CHP. That's a boiler that sits inside the house, and inside the boiler is an electricity generator, generating electricity while you use it. There's then evolving and emerging technologies for storage, so that if you've got power that's produced in the daytime when the sun's shining, you can store it with battery storage or compressed air storage or flywheel storage, and use that at times when the sun isn't shining. And then you've also got a number of things that are happening around energy efficiency, which are also distributed. And a good example of that is the new energy efficient LED light bulbs. So those light bulbs, an LED one is roughly 10% of the power consumption that you would have from an equivalent brightness coming out of an incandescent bulb. You think that's 90% reduction in the power consumption. Here in the UK, 20% of our electricity load is lighting. So that's 18% reduction that one could see from that. So it has a massive impact on utilities.
How is this impacting on the industry?
Well, it's really having quite a material effect on the industry. And I'm just going to look at photovoltaics by way of illustration. In Europe today, we now have nearly 90 gigawatts. So just to put that into context, that's more than EDF's total nuclear fleet in France and in the UK, which is about 75 gigawatts. Germany has about 38, 40 gigawatts of that, and last year it produced 7% of their total consumption. Now you say impact. Well, actually, when you step back and you look at it, utilities only own about 5% of that. So they've lost those revenues into the foreseeable future by this disruptive technology being deployed at the point of consumption. And it's not just in Europe. If we look at the US as an example, the US now is over 18 gigawatts of solar PV. And in Europe, we would have considered them the laggards. A third of that went in 2014. And a quarter of that has gone in without any government subsidies. So very often we say, well, what's driving this is the incentives that come from government in Germany, in the UK, and across Europe. But these products are all now coming to be price competitive and able for consumers to deploy.
So tell us about some other digital disruption that's impacting the industry and how this is accelerating its transformation.
It's interesting, I laugh a bit, because there's three things again there that are driving this change, right? The first one is very much in the area of these distributed resources that we've talked about. The second one is Internet of Things. And people sort of Internet of Things, big buzzword, but what it means is you can take all of these devices and start to connect them together. And you can do that with appliances. So that LED light bulb that I talked to you about, that could have sensors in it that starts to look at whether there's people in the room and therefore adjust the brightness, further reducing demand that's sitting in the premise where they're located. It could be smart appliances, so washing machines being connected. It could be security systems connected, looking at where people are in their rooms. And the thing that's striking is you've got relatively low-cost technology for generation energy efficiency that can be deployed very often with government incentives, so low capital. You've got Internet of Things that allows you to connect these things and have them talking to each other. And then you've got the ability for new startups to offer those solutions using cloud services that they can access easily and at low cost. So the new incumbents coming in do not have the capital challenges that the utilities that are placed there today face up to.
And how will this impact on consumers? Are there any companies who are driving this change?
So I think there's two examples that I like to look at. The one example is Tesla and SolarCity. So I think we all know Tesla. They make the electric vehicles, and Elon Musk is the co-founder, chairman and president of that. He's also the co-founder and chairman of SolarCity. So on the one hand, we've got Tesla, who build electric vehicles and are building a gigafactory for batteries, which in 2017, when it comes online, is reported in the press to have the potential capacity to build all of the capacity of lithium-ion batteries that were built in the world in 2013. On the other hand, you've got SolarCity that started out installing photovoltaic panels. They've gone vertically integrated and they manufacture those PV panels, and they are also building a gigafactory with the sole intent of getting the price per watt installed down below $1. Now, below $1 per watt installed, it is price competitive with all centralized generation without the losses that drive that. And you would have seen in the press that earlier in this year they announced that between Tesla and SolarCity they will offer home storage to their customers to be able to store the power that's produced from their solar PV. So that enables an individual domestic consumer with storage behind the meter on a power purchase agreement for their solar PV to go completely independent of the grid and grid disconnected.
Graham, speaking personally, what's the most exciting thing that you can see in the future having a real noticeable impact on people's everyday lives?
I think for me the most exciting thing is the fact that we're going to see lots more distributed generation, energy storage and energy efficiency coming into our personal lives and our working lives. So at home we can see things where we have devices and appliances connected to what we're doing with energy generation. And it's all part of solving the problem that we face with carbonisation of the environment, what we need to decarbonise and to stop global warming going above the dreaded 2 degrees.